Assalamualaikum warahmatullahi wabarakatuh. So now my group wants to present the video about extremum of functions. Extremum of function. It is about the nature of critical point from three-dimensional or 3D graphs. This is the example that we can see for the first one. It is a local minimum, and the second is local maximum, and for the last one is saddle point. First, we go to maximum point and minimum point. Maximum point is the output of a function at a local maximum point, which you can visualize as the height of the graph above that point is the local maximum itself. Same goes with minimum point, the output of a function at a local minimum point, which you can visualize as the height of the graph below that point is the local minimum itself. At the right here is an example for maximum point, and for the left example for minimum point. Next, saddle point. Okay, saddle point is the point at which fx or at which fx does not exist are called critical points, and a point of extreme must be one of critical points. However, there may exist a critical point which is not a point of extreme. Okay, we can see that the example of saddle point is here and here. This is formula for second partial derivative test. T as a second partial derivative test equal to fxx times fyy minus fxy square. If t greater than 0 and fxx less than 0, it will be maximum point. And if t greater than 0 and fxx also greater than 0, it will be minimum point. For the saddle point, t is less than 0, and if t equal to 0, it will be no conclusion.
Alright, let's do the question number 1. This is the equation. And the first thing that we need to do is we have to find fx, fy, fxx, fyy, fxy which equal to fyx. Okay, let's start the first one. Fx, we will get cs square minus y square plus 10x and must equal with 0. Fy, negative 2xy plus 2y equal to 0. And this is the first equation, and this is the second equation. Okay, let's do the fxx. We will get 12x plus 10. Fyy, negative 2x plus 2. Fxy, negative 2y. Same goes with fyx, negative 2y. Okay, from the equation number 2, this is what we will get. Negative 2xy plus 2y equal to 0. Okay. 2y minus 2xy equal to 0. 2y bracket 1 minus x equal to 0. So we will get 1 minus x equal to 0, so x equal to 1, and the other one is 2y equal to 0, So y equal to 0. Okay, let's continue. We get x equal to 1 and y equal to 0. So we substitute y equal to 0 in the first equation. And this is what we will get. 6x squared plus 10x equal to 0. Okay. Then we factorize it. We will get 2x bracket 3x plus 5 equal to 0. Okay. 3x plus 5 equal to 0, and x equal to negative 5 over 3. On the other side, we will get 2x equal to 0 and x equal to 0. Okay. Next, what we will do, okay, this is number 1 and this is number 2. Let's substitute when x equal to 1. Okay. When x equal to 1, we will get 6 minus y squared plus 10 equal to 0. And we will get y squared equal to 16. Hence, y equal to plus minus 4. So, so what are the critical points that we get from these two? Are so this is the critical point. The first one is 0, 0, then negative 5 over 3, 0, then 1, 4, and 1, negative 4.
Okay, so let's continue. I will continue for the table for we find the D and the conclusion. So for the critical point that we get before this is 0, 0, negative 5 over 3, 0, 1, 4, and the last is 1, negative 4. For the f(x)(x), we need to substitute the critical point to the f(x)(x) that we get before this. So, when we substitute, we get the answer for the f(x)(x) is 10, negative 10, 22, and 22. Same goes to fyy. We need to substitute the critical point to the fyy that we get before. So the answer that we get is 0, 0, 0, 0. For the fxy, we need to do square. Substitute the critical point for the in the fxy, and then we need to square the equation. So we get the answer 0, 0, 64, and also 64. For the D, we need to use the formula that the book gives is f(x)(x) minus fyy minus fxy square. Use this to the this for get the D. So for the first critical point, for the first equation, this one, for the first answer for D is 20. Second is The answer is negative 160 over 3. The third is negative 64 and also negative 64 for the last. And for the conclusion, we have two possibilities for the fxx. If we get negative, that means the conclusion is critical point. If we get the positive in the we get two possibility. When fx we get positive, so that means the conclusion is minimum point. But if we get negatives for the fxx, the conclusion will be maximum point. So that means d is greater than 0. And this one for the d, the answer has negative. So that means d less than 0. D less than 0 is mean the saddle point. Same goes to this. It's negative. The last is also negative. So that means D less than 0. This one also D less than 0. So for the the last two conclusion is also saddle point. This one also saddle point. So the conclusion for the final is we get minimum point for the first critical point, saddle point for the second and third, and also for the saddle point. So this is the final answer that we get from the question. For the question, that's all for us. Thank you.